What I'm about to show you can be achieved using handwritten notes, but the basic idea is the same. It's an evolution of my note-taking experience on the Surface Book 3. Now this has a pen, and I started by handwriting all my math notes. However, I eventually evolved into typing my math notes, and that was for the better. And here's why. So if you want my review of my 2 years spent with this beast of a machine, it's coming soon. So our goal is to integrate the taking notes experience with learning and studying the content at the same time, so you can reduce the time that you're spending studying. To do that, if we focus the notes on memorability and intuition, that helps the best. Because if you make your notes memorable when you write them, that reduces the amount of time spent trying to memorize them after you've written them. Even if your intuition is incorrect, it helps you grasp the concepts and remember them intuitively so that you can use them in your homework assignments, diagnostic tests, etc. We're going to use a sort of enhanced Feynman's technique in order to do this. If you don't know what Feynman's technique is, I'll link some helpful resources in the description. Feel free to check those out. So here are the 3 steps to typing your math notes and therefore spending less time studying. Step number 1. Don't write anything down that you can just reference later. That includes theorems, definitions, formulas. Instead, do step 2. Use Feynman's technique and explain it as if to a 6-year-old, or if it's a really difficult topic, at least a peer. And by that I mean in plain English, as if you're in an English class trying to write a sentence. This works because it simplifies concepts down into memorable tidbits, and it's memorable because of the mental effort required to translate the jargon into so-called baby talk. So you're effectively studying using Feynman's technique while you're taking notes. But here comes the important part. What if you're taking too long to figure out how to reword this into baby talk and the lecturer is moving on, or you don't understand it well enough yourself to reword it? And that is step 3. If you don't understand something well enough and give it a go, try to translate it into something memorable. But if you can't do it and the lecture is moving on, then create a symbol that you can put in your notes that you can go back to after the lecture is done as soon as possible and research using online resources or the textbook, and then fill it in with what you've learned as if you're explaining it to a 6-year-old or to a peer. I know OneNote has this really great shortcut, Control 3, which brings up a question mark tag, which you can then search later, all the question mark tags, and find everything that you were unsure about. Finally, here are the use cases for using the typed math notes method. The first one is trivial and is left as an exercise to the reader, using it in a lecture situation. Pretty much how I've been describing it so far. Second and third ways, not so much. So second and third, we have textbook pre-reading and self-learning. They're essentially the same thing. So if you can pre-read your textbook using the typed math notes method, then the lecture time becomes a time to fill in the gaps where you put the question mark symbol. And this method works great for self-learning because you don't really sit in the lecture. You just do the textbook pre-reading part. And being able to go through each theorem definition and rewrite it in your own words intuitively and grasp the concept is very important. I'd even go as far as to say that when you're solving problems and doing the exercises, because you should be if you're self-learning, to write them in a way as if you're explaining them to a 6-year-old. And everything I've gone through so far should help you learn lots and learn efficiently. Keep learning. You've just spent the time to